All right, we're now recording. And let me try to share the screen again. And I'm having trouble with sharing the screen. Not a good sign. I'm getting that swirly circle, which is not good news. Okay, we'll try it again. That's not working, folks. Okay, I'm going to try shutting off the document camera and turning it back on. You guys can just relax. You got a little mini break as I try to get this working. And it's still not working. Nope, still not working. I'll try this one more time. Okay, folks, it looks like it's not working right now. So the only other thing I might try in about a minute is to close the meeting, reboot, and try again. So let me try one more minute, see if I can get this working. Now it looks like you can't even see me. I can't see myself. Okay, I can see myself also, thank you. But I'm not getting my document camera to work. And it's not really easy for me to teach without it, so try one more time here. Well, you're getting a nice break anyway. There we go. Okay, I think we're finally good. So what do we lose, 5 minutes? That's the way it is when we're teaching under this COVID environment, right? All right, although I've had this happen before and then the document camera goes out on me after a while too, but be that as it may. Okay, so if you're looking at the recording later, I guess the first 5 minutes are garbage, as you probably know, unless you like to spend the first 5 minutes seeing me make a fool of myself, then just fast forward the first 5 minutes. All right, we're over here, we're doing the product and quotient rules. So again, we're aiming for about 3 sections a week. So 3, 3, 3, 3, that'll lead us to the next exam, which is Friday the 26th. That's just before the spring break. So that seems to be a natural time to have the exam. Okay. So now that I've lost 5 minutes, well, that's okay. We'll see how it goes. All right, so the key ideas are the product and quotient rules. And in fact, as I mentioned at the end yesterday, page 187, this is a nice summary of derivative formulas just for sections 1 and 2. That's not everything. We still have sections 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Okay, but we're focusing now on the product and quotient rules. Fg prime is Fg prime plus Gf prime. First times derivative of the second plus the second times derivative of the first. Quotient rule, F over G prime is Gf prime minus Fg prime divided by G squared. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the square of the denominator, okay? And you're never going to be able to cancel these out. You look at this G, you'll see a G squared. You may want to cancel these out, but try to prevent yourself from doing that. You're not allowed to unless this thing comes out to be 0, which it almost never does. Okay, so everything up to here, this was section 1, those 1, 2, 3, 4, 5, 6, section 1, and now section 2, product and quotient rules. Okay, so we'll try to do some product and quotient rules, and hopefully if I have time, I'll let you do some in class. All right, so some problems from 3.2. Now, whenever you can make things easier on yourself, you should. Okay, so 3.2 number 9, it was u minus, that's a minus, u minus radical u, u plus radical u. And the key thing for that is, why do the product rule when you don't have to? Clean it up first. That looks like a minus b, a plus b. So that's going to be u squared minus radical u squared, which is u. So u squared minus u, that becomes easy. Don't need any product or quotient rule. H prime of u is 2u minus 1. So that's all there is to it, right? Okay, number 7, first example of the quotient rule, 1 plus 2x over 3 minus 4x. Okay, so quotient rule, put it on your formula sheet. Again, if we were meeting face to face, I'd make you guys memorize it. Okay, maybe the next time we're on campus, your next teacher might make you memorize it. Okay. So 1 plus 2x over 3 minus 4x. So g prime of x is the bottom, copy the bottom, not the derivative of the bottom, just copy the bottom, times the derivative of the top. What's the derivative of the top? 2. Minus, I know it looks like plus, but temporarily pretend it's a minus. The top, 1 plus 2x, times the derivative of the bottom. Derivative of the bottom is negative 4. So what I'm trying to indicate here is that that's a double negative. So in red, I changed the minuses to a plus. All over the square of the denominator, 3 minus 4x squared. Okay, clean it up. Usually for the quotient rule, it's worth it to clean up the top, but not the bottom. And this is what I'm talking about in terms of cancellation. Can I cancel this 3 minus 4x with this 3 minus 4x? The answer is no, not when you add or subtract something. Okay, so just clean up the top. So distribute the 2, 6 minus 8x plus 4 plus 8x divided by 3 minus 4x squared. 8x cancels out. So final answer is 10 over 3 minus 4x quantity squared. Okay, so that's how the quotient rule works. Okay, 17, e to the p times p plus p radical p. Okay, it looks like it's going to be a quotient rule. Okay, and I'm going to change p radical p to p raised to the 3/2 power. Okay, and don't be surprised if you don't use your favorites y and x. Sometimes they'll sneak in a p and a q and a w or whatever, but it's the same thing. Okay, this is p to the 3/2, p to the 1, p to the half. So p to the 3/2. So this is the first function, second function. Okay, then I use the product rule. right? F G prime plus G F prime. First times derivative of the second plus the second times the derivative of the first. Here's the first, here's the second. So copy the first, e to the p, and then times the derivative of the second. So I differentiate this. Again, when I say differentiate, it means take a derivative. Derivative of p is 1 plus 3/2 p to the 1/2, right? Plus second function, p plus p to the 3/2 times the derivative of the first. What's the derivative of e to the p? Itself, e to the p. Okay. And in this particular case, I'm not going to worry about simplifying it. It kind of depends. Now, if it comes to a quiz or a test, or you're saying, should I keep going or not? It kind of depends. I'm not overly emphasizing the algebra. I mean, you want to know basic algebra, but this might be too much work to combine everything. So I'll just say leave it. Okay. Okay, this one looks like a quotient rule. F of t is cube root of t over t minus 3. And let me check that problem number. Yeah, that was problem 21. All right, so this is t to the 1/3 power, right? So when I differentiate, I'm going to use that as t to the 1/3. I do hear a little bit of background noise there, so can you all make sure that you're muted? Okay. All right, so I'm using this quotient rule. So here we go. Bottom, t minus 3, times the derivative of the top. So what's the derivative of t to the 1/3? It's 1/3 t to the 1/3 minus 1 is negative 2/3. Minus the other way around, top times derivative of the bottom. So the top, well, since I'm just copying it, I might as well write it in radical form, cube root of t, times the derivative of the bottom. What's the derivative of t minus 3? That's 1. And yeah, you don't really have to write the times 1. All over the square of the denominator, t minus 3 squared. Okay, and yeah, again, in this case, we're just going to leave it. You could do more, but we don't feel like it here. It's very messy. And can I cancel this t minus 3 with one of these t minus 3? No. Okay, in general, you're never going to be able to do that. Okay. 23 is quite messy, I think. F of x is x squared e to the x divided by x squared plus e to the x. Yeah. That looks like a quotient rule, right? So it's a quotient rule. But over here, somewhere I have to differentiate the top. The derivative of the top is a product. So there's a product rule inside the quotient rule. Okay. Somebody's still not muted. Can everybody please mute yourselves? I don't know if I have to. Sorry, folks. I really shouldn't have to do this, but I am trying to figure out who's not muted, but I don't think I can spend all that time doing that. All right, so here's how complicated it gets. So it's bottom times the derivative of the top, right? So copy the bottom, x squared plus e to the x, times the derivative of the top. But in the process of differentiating the top, how do I differentiate this? Product rule. So there's a product rule inside a quotient rule. So first times derivative of the second, x squared times e to the x, plus second function, e to the x, times derivative of the first is 2x. Okay, so all of that is bottom times derivative of the top. Minus the top, x squared e to the x, times the derivative of the bottom, that should be an e to the x there. But that's not really that big of a concern. Okay, so what's the derivative of the bottom? Derivative of x squared is 2x plus derivative of e to the x is itself. All over x squared plus e to the x squared. Okay, so that's the derivative. And once again, in this particular case, the top is so messy, we'll just leave it alone for now. That's the essence of it. Okay. So we're doing the product rule and the quotient rule right now. All right, 27. This looks like a product, x cubed plus 1 e to the x. First function, second function. Right, so it's f g prime plus g f prime. You take one times the derivative of the other and then switch it. Yeah, another thing to watch out for, make sure if you're putting this on your cheat sheet, you get it exactly. Notice for the product rule, there's a plus. For the quotient rule, it's a minus. Okay. Now there's some similarities. Like if you look at the product and quotient rules, right? They both have the idea of, okay, you take one times the derivative of the other, and then you switch it. Okay. However, for the product rule, there's a plus, and for the quotient rule, there's a minus. And then for the quotient rule, you have to divide by g squared also. All right. So copy the first one, x cubed plus 1, times the derivative of the second. So what's the derivative of e to the x? Itself, e to the x. Plus second function, just copy it, times the derivative of the first. So what's the derivative of x cubed plus 1? 3x squared. Okay, and in this particular case, it's worth it to keep going. It's pretty easy to factor out the common factor of e to the x, right? So if you factor out e to the x, you have x cubed plus 3x squared plus 1. Okay, and that actually does make it easier when you have to take the second derivative now. Okay, because for problem 27, it asks for the first and second derivative in this particular case. So now to find the second derivative, f double prime, it's the derivative of the derivative. Notice after you differentiate, the thing that comes back out is another function. Right? I mean, if the problem just started off like that, yes, ignore the fact that they came from a derivative. If you just pretend you started from here and say, oh yeah, I can take a derivative. It happens to be the derivative of this one. So yes, I'm taking the derivative of a derivative, second derivative. So I differentiate this. First function, second function. So again, copy the first and then multiply by the derivative of the second. So what's the derivative of e to the x? Itself, e to the x. Plus second function, e to the x, times the derivative of the first. So I need to differentiate this polynomial. That's not too hard. So x cubed becomes 3x squared. Derivative of 3x squared is 6x, and the derivative of 1 is 0, so you don't have to write it. And once again, it's pretty easy to factor out the e to the x, right? So I took out the e to the x. I have x cubed plus 3x squared plus 1 plus 3x squared plus 6x. So it looks like I have x cubed. I have 3x squared plus 3x squared, which is 6x squared, and then 6x, and then 1. So there we are. Okay. All right. Okay. Then 35. We have recurring themes again. Find equation of the tangent line. Let's see, 33, find equation of the normal line. Okay, we know what that means. Normal means it's perpendicular to the tangent. So once you find a tangent, okay, let's say it comes out to be negative 2/3. Take the negative reciprocal to find the normal line slope. So if you have negative 2/3, flip it and change the sign, that would be 3/2, right? All right, 35, y equals 1/1 plus x squared. It's called Witch of Maria Agnesi. Don't worry about that. Okay, it looks like an inverted witch's hat, but in any event, find the equation of the tangent to the curve at the point -1/2, and ignore part B. I think I said already, right? Anytime you see this graphing calculator icon, skip it and don't worry about it. Once again, this has a graph. You're at a certain point. Find the equation of the tangent to the curve at that point. All right, so y equals 1 over 1 plus x squared, quotient rule. All right, bottom, 1 plus x squared times the derivative of the top. What's the derivative of 1? 0. I like that. So that's all gone. Minus the top, 1, times the derivative of the denominator. Derivative of the denominator is 2x. All over 1 plus x squared squared. So a little bit of cleanup, negative 2x over 1 plus x squared squared. Okay, so that's the derivative anywhere. Now I want it specifically at one point. At one particular point, give me the equation of the tangent line. So I'm at negative 1, 1/2. So negative 1. So what do I do with the 1/2? Well, that's the y coordinate. I would plug in if it said any y, but there isn't any y. There isn't going to be any y for a while. Section 5 or 6, your derivatives are going to have x and y. Then I have to plug in x and y, but I'll tell you when that happens. Okay, so I just plug in negative 1. Put a negative 1 there, negative 1 there. So I have negative 2 times negative 1 over 1 plus negative 1 squared, and that whole thing has to be squared. So negative 2 times negative 1 is 2. This is 1 plus 1, right? So that's 2 squared, 2 over 4, 1/2. All right, then I have my point slope, y minus y1 equals m times x minus x1, stop. That's it. Okay. Problem's finished, but I'll dig a little deeper. Okay. The graph happens to look a little bit like that. Okay, and they gave us a point negative 1, 1/2. I'm not even putting the x and y coordinates. It doesn't really matter. Okay, so you're somewhere here. There's a tangent line, right? That's the equation of that tangent line. That's what we're getting by doing this stuff. Okay. All right, so that is that. And now let me see what else I wanted to show you. I had some question about previous problems, so let me go back and do them. I had a question about 3.1, number 53. So let me go back and do that one. Page 181. Okay, Boyle's law. It's a law from chemistry and physics. So maybe some of you chemistry and physics people have had Boyle's law before. States when a sample of gas is compressed at a constant temperature, the pressure P of a gas is inversely proportional to the volume of the gas. Okay, then they give you all this data that we plug in. Look at part B, dV/dP, rate of change of volume with respect to pressure. Okay, so you do want to get somewhat comfortable with this Leibniz notation. Okay, there's a future section where the whole thing is all Leibniz notation, just a bunch of D's, ds, dt, dx, dt, and so on. Okay, dv, dp, and all of this. Okay, so let me show you what is done there. So it said pressure is inversely proportional to volume. If you multiply both sides by V, you get PV equals a constant, which is maybe the way some of you learned that in chemistry or physics, right? Pressure times volume is a constant, okay? But pressure is inversely proportional to volume, P equals K over V. That means when pressure goes up, volume goes down and vice versa. That kind of makes sense. So if you have a gas, right, it's in a confined space and then you apply pressure to it, like you push down on a piston, the pressure increases, then the volume decreases, right? Because the gas gets scrunched more. All right, so you just plug in stuff. They told me 50 goes here, 0.106 goes here, multiply, and you get K is 5.3. So I plug in 5.3. So P is 5.3 over V. Okay. They want dV, dP, so I switch these around. Okay. I'm not sure if I told you before, or you may have heard me if you took me before, but there's a rule in algebra that you're allowed to switch these two. You can just put the V here and a P here. So if P equals 5.3 V, then V is equal to 5.3 V. You may do that shortcut if you wish. Have you ever heard of that before? You can just switch these two. Okay, so P equals 5.3 V means the same thing as V equals 5.3 over P. Okay, a very quick timeout. It's very obvious if I pick real numbers like 3 equals 15 over 5. Is that true? And it's true if I switch them around. If I switch them around, it says 5 equals 15 over 3. Okay. You can show it algebraically, but I'll let you do that shortcut. You can always just switch these two if an equation looks exactly like that. Okay. Something equals fraction, you're allowed to just switch these two. All right, and this is 5.3 p to the negative 1. All right, so dv dp is negative 5.3 p to the negative 2, right? Negative 1 comes down and hits 5.3, negative 5.3 p to the negative 2, and then rewrite it, quote unquote, normally, negative 5.3 over p squared. Okay, then in the second piece of data they give me, they tell me to plug in p is 50, so I put 50 right here. So dv dp is negative 5.3 over 50 squared, punch it in a calculator, negative 0.00212 cubic meters per kilopascal. Okay, the units are the units of volume, which in this particular case was meters cubed, and units of pressure is kilopascals. So that's all. So the rate of change of volume with respect to pressure at a pressure of 50 is this much right over here. Okay. All right, and let's see, do I want to do, yes, question was asked about 59. 59 in section 1. Find equations of both lines that are tangent to the curve y equals blah, 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 and are parallel to the line 3x minus y equals 15. Okay, so parallel to that line. So first I have to figure out what that slope is. All right, so if I move over the y and subtract the 15, 3x minus 15 equals y. That looks like mx plus b. So the slope I want is 3. Okay, so the way to do this is to set the derivative equal to 3. Derivative means slope, slope of a tangent line. Okay, so instead of setting it equal to 0, I set the slope equal to 3. So what's the derivative of this? That should be pretty easy. 3x squared minus 6x plus 3, and the derivative of negative 3 is 0. Set it equal to 3. Okay, so again, the derivative of this is this. Set it equal to 3. If I subtract 3 on both sides, I get this. Factor out the 3x. 3x, x minus 2 equals 0. So x equals 0 and x equals 2. Okay, they want you to translate that to points. So what are the points? Well, 0 is easy. Okay, 0, I plug in 0, 0, 0, 0, 3, negative 3. Okay, you figure out the 2. So I left it open, but just plug in 2 here, 2 here, 2 here, and it's 2 comma something. It's the answer to that one. Okay, so I wanted to show you at least that one also. Okay. All right, then going back to 3.2, wanted to show you 31 also. Okay, 31, find equation of a tangent line at the specified point. So y equals blah, blah, blah at the point 1, 0. Okay, so again, it has some curve. What does it look like? I don't know, I don't really care, but there's gonna be a tangent line. What's the equation of the tangent line at 1, 0? Okay, so quotient rule. All right, so bottom, copy the bottom, times the derivative of the top, 2x, and then minus the other way around, right? X squared minus 1 times the derivative of the bottom. So what's the derivative of the bottom? 2x plus 1. all over the square of the denominator. Okay, so take the square of the denominator. Okay, and this time, rather than trying to clean it up, let's just go straight to plugging in 1. And plugging in 1 is nice because look at what happens when you plug in 1 right here. 0. So forget about this whole thing, right? That's all 0. So 1 plus 1 plus 1 times 2. 1 plus 1 plus 1 squared. So that's going to be 3 times 2 over 3 squared, 6 over 9, 2/3. So 2/3. Point, slope, y minus y1 equals m times x minus x1. And again, you may stop right there. That's good enough. Okay. All right, that's that problem. Now we have some rather interesting ones a little bit later. Let's see. How much do I want to do here? (3.241) x squared over 1 plus x. Find f double prime of 1. Okay, so I have to find a second derivative and then plug in 1. Okay, so that gets a little bit clumsy. X squared over 1 plus x. Find f double prime of 1. So first derivative, bottom times derivative of the top. What's the derivative of the top? 2x. Minus the top, x squared, times the derivative of the bottom. What's the derivative of 1 plus x? 1. So if it's times 1, you don't even have to write it. Over 1 plus x squared. Clean up the top. Don't clean up the bottom. Again, you're not allowed to cancel, right? You might say, oh, can I cancel 1 plus x, 1 plus, no. All right, so what do I have? 2x plus 2x squared minus x squared plus 2x. Over 1 plus x squared. Yes, that's equal to x squared plus 2x plus 1, but it's usually not worth it to do anything with that. Okay, now I need the second derivative, so I have to differentiate this mess. Okay. Yes, when I differentiate the bottom, I have to treat it as x squared plus 2x plus 1. That's right, sorry about that. So bottom times derivative of the top. So what's the derivative of the top? 2x plus 2. Plus the top, x squared plus 2x, times the derivative of the bottom. Now, we don't know how to differentiate something like this yet. We will shortly. It involves something called the chain rule. We don't know what that means yet, so we have to hold off on that. But keep in mind, it's the same as x squared plus 2x plus 1. So what's the derivative of this? 2x plus 2. All over the square of the denominator. So what is 1 plus x squared squared? It's 1 plus x to the 4th power. All right, now that we're plugging in, don't bother to clean up the algebra. You could. It's way easier to switch over to numbers, right? I mean, we're all more comfortable with numbers than with letters. So they want f double prime of 1. So I just plug in 1 everywhere. 1 there, 1 there. Every x gets a 1. So it's 1 plus 1 squared, 2 times 1 plus 2, 1 plus 2, 2 times 1 plus 2, over 1 plus 1. That's a mistake there. That should be to the 4th power. Sorry. So it looks like I goofed here. So I have to change this. So that becomes, let's see, 2 squared of 4 times 4, 3 times 4 over 2 to the 4th power. Okay, it should be a 2 to the 4th power. Okay, sorry, I messed this up. So that's going to be 16 plus 12 is 28 over 16. And that reduces to 7/4. So it looks like it should be 7 over 4. Okay. All right, what time is it? Okay, I think we're okay. Then we have some unusual problems at the end. 43. Okay, 43. F of 5 is 1, F prime of 5 is 6, G of 5 is -3, G prime of 5 is 2. Find all of the following values. Okay, so there's a product for A, there's a quotient for B, another quotient for C. I was going to show you A and B. So let me show you how that works. So 43. To give me all this data, F of 5, F prime of 5, G of 5, G prime of 5. Okay, they want F G prime of 5. So first I write the quotient rule in general. F G prime of X is F G prime of X plus G of X F prime of X. Now I plug in 5. F G prime of 5, put a 5 here, 5 here, 5 here. So F of 5, G prime of 5 plus G of 5, F prime of 5. And I just plug in. I plug in from all the data that you give me. So F of 5 was 1. G prime of 5 is 2 plus G of 5. G of 5 is -3. And then F prime of 5, they told me was 6. Okay, so you just put all the pieces together. So 2 minus 18, -16. Right. And then B, quotient rule, F over G prime of 5. So it's G of 5, F prime of 5, minus the other way around, F of 5, G prime of 5, all over G of 5 squared. So you can just plug everything in. So G of 5 was -3. F prime of 5 was 6 minus F of 5. F of 5 is 1. So I'm just plugging in. G prime of 5 was 2. G prime of 5 is 2. All over G of 5 squared. That's -3 squared. -3 squared. Okay, just clean it up. So that's going to be what? -18 minus 2 over 9. Final answer is -20 over 9. Okay. All right, folks. I'm not quite done with this section, but I can continue tomorrow. I think we're okay. So I'm going to stop and let you do some of this in class. So get your cell phones out to take a picture or be able to do a screenshot. So we're here. I'm not quite finished with 3.2. I'll take a few minutes to do that next time, and then we'll start 3.3. Okay. All right. So in class right now, when you have the answer, just type it in the chat. Okay. So one product root and one quotient root. Okay. I want you to find these derivatives. So number 1, y is x squared e to the x. 2 is y equals x minus 1 over x plus 1. Okay, and again, to type exponents in the chat, exponent, you go like this, right? E, you can just type regular E. Division is like so. You might have to put parentheses, right, to indicate that. Okay, so again, number 1, y equals x squared e to the x. Number 2, y is x minus 1 over x plus 1. Find the derivatives. Okay, and yeah, how do you write derivative? Y prime, or you can write dy dx. Okay, when you're done, if you have no other further questions, put it in the chat and you may leave after that. Okay, I'll hold it for maybe 15 more seconds. Anybody who still doesn't have it, you probably have time to write it down now, frankly. Okay, so if you can't take a picture or you can't do a screenshot, write it down. First one is x squared e to the x. Second one is x minus 1 over x plus 1. Hold it just for a few more seconds. Okay, when you're done, type your answers in the chat, then you can leave unless you have any other questions. Okay, I'm going to make it disappear. I will assume that you all have it now. So I'll stop the share. I'll also stop recording. There's no need to